Little shout out to all you plant managers, maintenance managers, operations managers. A little discussion today. You all have some form of maintenance planning. There are three main forms. There's the one that a lot of startups have because they just haven't had time to truly plan things out, and that's fix it when it breaks. Then when you get going a little longer and you get a little bigger and you get a few more people, then you actually come up with preventative maintenance planning, which works better, which saves you a lot more money, obviously, because you're not having to downtime. You're planning when you are doing maintenance and replacing parts because everything eventually wears out. But then there's a third form that has become possible through automation and instrumentation, and that's called predictive maintenance planning. Now, when you have to fix something that breaks, you have downtime, you have to expedite parts, which can be expensive, and sometimes they just don't exist to be expedited, so you actually have to wait that week or two. You have to deal with downtime, loss of process. You have to get people in on overtime to do the repairs, etc., etc. It's horrific. You get a little few more hours out of operation out of the parts that die, but then they're dead, and then you lose all that time in the end. With preventative maintenance planning, which is what most people do, you plan your downtimes, and you figure, okay, it's kind of like with your car, with your oil. You say, oh, we got to change the oil every 5,000 kilometers. Why 5,000? Is the person driving in a city the same as the person driving in a country where all the dust gets kicked up by the gravel roads? Is the person driving up and down hills in the mountains doing the same damage as the person who's driving in the country? Is the person who's driving in the city with a lot of idling? It could be, for every hour of driving could be 2 hours of idling. So your hours of operation don't match your mileage. But you see, there's a whole slew of variables that are not considered in this 5,000 kilometer number. That's the same in your plant. Oh, we're going to, change out our bearings at such and such. Why? Because it's a number. And it often has no bearing, pun intended, on anything other than somebody's number, some average. So the advantage of predictive maintenance is we're taking qualitative and quantitative samples from the plant. We're analyzing the numbers we're getting, and based on the returns on that data, we can plan exactly when we need to change things. We're monitoring those bearings. Is it 5,000 hours of operation on that machine? Or can we get 10? Or do we have to change it in 3? What's actually going on? Our seals, do we change them after a certain amount of operation? Or do we use predictive maintenance and find out how long they're going to last? Here's the advantages. Advantage number 1. You get the full life out of everything you're changing out. You're not throwing it away when it's still got a few weeks or months or sometimes even years worth of operation in it. Number 2, nothing's breaking. So the maintenance happens on things before they break. With preventative maintenance, every one of you in maintenance knows, preventative maintenance, that's not always the case. That 5,000 hours may be too long, right? You've done it. Oh, well, why did it break? Because nobody was actually monitoring it, because you didn't have a system in place for that. You just guessed at a number, the number was wrong. So with predictive maintenance, you're actually monitoring, it doesn't get to the point where it breaks. Number 3, like the preventative maintenance, you get to schedule when it gets replaced. You go, okay, we're at this point now. On Thursday, we have to do this, this, and this. We can get these 3 things done. We can do a schedule for 11 o'clock, and by 1 o'clock after the lunch break, everything will be up and running again. So think predictive maintenance. There's a more CapEx to it because you have to buy the sensors, etc., which today are relatively cheap, not like they were in the 80s, 90s, when they were blisteringly expensive and nobody used them because we didn't have the computer power. Now everything's cheap, everything's mass manufactured, so we can put in the sensors we need where we need them It's a small upfront capex expense, but it saves you a ton. The first time, the first broken thing, it saves you, it's paid for itself. So when you're looking at your maintenance, don't think reactive. Don't even think preventative anymore. Think predictive maintenance. How can we put in a system of sensors and computer technology, most of which is already there because everything's already been controlled by PLCs and DCSs in your plants. What can we do? How can we do it to predictively fix things, to give them the longest possible life, fix them before they break, save us a lot of money, and have no unscheduled downtime? Predictive maintenance is the solution to the modern plant.